So to finish up 7.3, there was the second half of 7.3 is a graphing component. So when you go to graph it, the parent function is y equals log base b of x. And then our translated, stretched, compressed, and reflective function is y equals a log base b x minus h plus k. So the translation is whatever h comma k is. The stretched compressed part is by a factor of a. And the reflected piece, if it is negative a, then it's x-axis. And if it is negative x substituted for x, then it's y-axis. This should be slightly familiar from previous chapters. Remember when we did translation, dilation, stretch, compress, we talked about compress makes it fatter, stretch makes it taller. So we didn't, if you look at, let me show you how Desmos deals with this. You guys don't have to take notes on this because so if I'm using Desmos calculator, wait for it. Alright, so I have my parent function y equals log. Here, let's find it. Huh? Log. So right now it's automatically base 10. Alright, so you have the choice. When it doesn't have anything in the little subscript, like this one, this is base 10. And if you remember, that just means when you rearrange it, the b is 10.
It's always base 10 if you don't have one.
Yes. It's always base 10 if there's no subscript. So here, let's go, let's graph base 4. And we'll make this the parent. So we'll find our parent function. Y equals log base 4 of x. Okay, so that's what it looks like. And if you compare it to y, record. So if you look, if you wrote this as an exponent, it would be, usually our exponential functions go, we did this last week, they come up here. This one is an inverse, so it's same shape but rotated, and that's how you can tell they're related. Okay, so now we're going to translate this. Claire, let's pick a number for a. If you look at the parent, we got our parent function down. So what number are we going to put here? Just pick a number between 1 and 10.
2.
2. So on Desmos, we're going to go 2. We're going to go, we have to have the same base, log base 4. And then, Maddie, let's translate it left or right. And so how far, do you want to go left or do you want to go right? Okay, we'll go left, so that means a plus here. And how many units left? 7. And then, Erin, do you want to go up or down? Down, so that would be a minus. And how many units?
3.
So we just took this red function, we moved it, we did a vertical stretch of 2, we moved it 7 units left and 3 units boop, boop, boop down. So that's the parent function relationship. All right, so 7.4 is properties of logarithms. And the learning objective is to use properties of logarithms. There are 1, 2, 3, there's 4, so let's make a little table. So we get the property, we have the equation. I'm going to need more room. And the example. Okay, so the product property says that if I have, I need more room. Sorry. I need more room. Not enough room. So if I have a log base b of m times n, that is equal to log base b of m plus log base b of n. The way I remember this is the equation rule for when you add, when you're multiplying things with the same base, is that you add the exponents. So this is kind of an extension of that rule. So log base b of m times n is equal to the log base b of m plus the log base b of n. Quotient is similar, but we are talking division. So log base b of m divided by n, so you have division within the log, is the two separated out, subtracted from each other. Log base b of m minus log base b of the power property is, if I have a power inside my log, I can take that power and put it out to the front and multiply it. And then the last rule is my change of base. And that's if I have log base b of a. It's the same as log a divided by log b. And what's the base here, Aaron? When you don't have the little subscript,
10.
it's 10, yeah. You can do base 10 and base e in your calculator. None of the other bases work, so you have to use change of base. Here are the examples. We've got, the instructions are write each as a single logarithm. And we've got log, the first one is log 8 plus log 3. So if I was to write log 8 plus log 3 as a single logarithm, I go back to my product property and I say you can actually use these properties backwards. So I can write that as 1 log with these two items multiplied together. So I can write this as 1 log with these two guys multiplied together. At the end of the day, it's log 24. What's the space? 10. Let's do that with subtraction. All right, we got to make sure our bases are the same. Here we're both base 10. Here we're both base 10. No subscript means base 10. So we're going to use the product property to deal with this guy. So this is log 5 minus log x squared, because the product property says that if I have an exponent on the inside your log, you can rewrite it as multiplying on the outside, but vice versa is true. So if I have a value multiplied on the outside of the log, I can write it as an exponent. So now that I have this, we can backtrack. We know that this is equal to, when you have subtraction, that means division inside the log. Log of 5 over x squared. Here, C, we're going to evaluate. Evaluate means you come up with a number. So we need to pull this 1/2 up onto the 15th. So that's log base 5, 15 to the 1/2, minus log base 5 of, are you guys, when we attack this, do you want to attack this in square roots or do you want to attack it in 1/2 power? You have the choice. Square roots or 1/2 power. You want to do square roots? Okay. All right. So now we are here. We got all of our stuff moved up into the exponents. Now let's deal with the minus sign. So we're going to say log base 5 of 15. 1/2 power is the same as square root divided by the square root of 75.
Why is it divided?
Because of the minus sign. When you have two logs with a minus, you can rewrite it as one log with dividing on the inside. I'm going to rewrite this with everything underneath the square root. (15/75), what does that reduce to? Can we comfortably say 15 divided by 5 is 3, and 75 divided by 5 is 8. Just make sure so you are confident in your answers. So now I'm going to convert this back to an exponent. What's my base here? 5. What? I want to see if there's a better way to write this. Hold on. I put an equal sign in there. That's fine. So 5, and we don't know what that equals, so we're going to call that x. So 5 to the x power is equal to the square root. Hold on. 3/15. Oh wait, hold on. What's 3/15, y'all? Thank you. So how do I go, what exponent do I apply here to get it to be root of 1/5? Well, let me show you a little bit. Is this not equal to so if I were to pull this 5 up to the numerator and make it a negative exponent, and then is not square root equal to 1/2 power?